Right, if we begin to label what we have, arc AE is given as 150, and then you're told the ratio of the remaining arcs. So if you're thinking in terms of part to part, okay, what you would think is you have 7 times some common multiplier. BD is 10 times that same multiplier, so we see it's not necessarily to scale here. DE is 4 times that same multiplier. So what you would know in this case, if you're thinking part to part to part, is that the sum of all these parts plus the given arc measure, 150, has to equal the whole, which is what? The whole rotation on a circle is 360. And so if you combine these, you get 210x plus 150 is equal to 360. Isolate your variable by subtracting 150 from both sides. Divide both sides by 21 to isolate your x completely. So you get x is equal to 10. And so now we can plug it back in. We want to find the measure of angle C. C is going to equal, the measure of angle C is going to equal 1/2 the difference of 150 minus whatever 10x is. So if x is 10, 10 times 10 is 100. And so we get 1/2 the difference of that. 150 minus 100 is 50. Half of 50 gives us our angle 25. Okay, now, there's another way, again, you can approach any type of ratio problem, right, and that's part to whole. Again, I'd encourage you to try to think in these terms. It'll make many of these problems a little easier to solve or more efficient, and it extends to the standardized testing that you guys will do for SAT and ACTs. If you're thinking in terms of part to whole, if you have 7 parts, 10 parts, and 4 parts, that means the total number of parts you have is what? You have a total of 21 parts, right? Remaining in this leftover portion of the circle's rotation. Okay, of those, how much is in the measure that you want to find? 10. So this arc, BD, represents 10 out of 21, 10/21 of the whole remaining arc measure. Well, if we know that 150 is accounted for, what's going to remain from these? It's this value, 210. And so you can find it directly just by taking the part to whole ratio. So 21 goes into 210 10 times, so we get 100 degrees. And so we can immediately derive this number, plug it in, and solve it the same way that we did right here.